welcome back. We're still on polymorphism. So assuming we have a class which is a base class called animal, and out of animals we get some subclasses such as horse, which is an animal, fish, which is an animal, bird, which is an animal, and more others. These are derived classes. So let us also assume that animal class has a function called move. So within the animal class there is a function called move, which is inherited by all subclasses mentioned. So the horse inherits move, fish, and bird. So with polymorphism, we are saying each subclass may have its own way of implementing the function. For example, when the move function is called in an object of the horse class, so we understand the horse using the move function may have its different way of implementing the move. The same move implemented by fish, we may call it swimming. For a horse, we may call it trotting. For a bird, we may call it flying. But you see, flying, moving, swimming, trotting are all instances of the move, or they are different versions of the move function. In effect, polymorphism basically it trims down the work of the developer, because he can now create some sort of general class with all the attributes and behaviors that he envisions. So when time comes for the developer to create some more specific subclasses, then those subclasses maybe will have some unique attributes and behavior. The developer can simply alter some portions of code to give him or what the desired behavior that he wants. So that is polymorphism. Advantages of polymorphism or importance is that when one object has a reference to another, it can invoke, or you can use the methods by virtue of reference without knowing or caring, or even really don't want to worry about how they are implemented. You simply use them because they are available. You really don't care how they work or how they were modeled. So why polymorphism? Because polymorphism can give us something called substitutability. It is a way we can have substituting variable types that do not match the exact implementation of what you want. You can substitute. We have seen from shape class, probably shape can get some other forms of classes, subclasses such as circle, line, and rectangle. So if within the shape superclass I had a method called draw and another one resize, then you see I can implement these methods using different parameters in the different forms, in the circle, in the line, and in the rectangle. Yeah. So that is an element of substitutability, where a method in the shape, a method in the base class can be substituted into, or can be substituted to mean something else in the derived class. Another thing is the extensibility of some of the code. So some of the code that is available in the superclass or base class can be extended in the, or a new behavior can be modeled, or you can add a new behavior to the subclasses, or by simply therefore getting extensibility or extending the behavior. You are basically extending the behavior of a shape. For example, now having talked about the issue of animals here, the move behavior in the animal superclass has been modeled to mean swimming. It's also swimming is a movement, trotting is movement, flying is movement. Now you see you're extending the functionality move in the subclasses. Yeah. Another thing is when you want to have a common interface. So with polymorphism, You can have a common interface that is available in all other objects that you model or in other subclasses that you model. Yeah, so if I have a superclass called shape, and this shape has a method draw and resize. So the method draw and resize are giving me some common interface to implement in the circle. I can draw a circle, I can resize a circle, I can draw a line, I can resize a line. So these are different derived subclasses. I can resize a rectangle, a triangle, I can draw it. So that is common interface that is made available by me having the shape. Another thing is upcasting, whereby now we're saying you can upcast, basically change a subclass into a superclass. So there's a lot of code there that you have to go through. Another concept that I want to talk about in relation to polymorphism is we call virtual functions and binding and whatever. So these concepts simply mean that there's some, when you talk of binding, we simply say when your program is running, it may bind to some new objects, or it may bind to some memory locations which did not exist when it was statistically being compiled. So the binding will refer to an object trying to address or trying to access some more resources during compilation and runtime. So if this binding is happening during compilation, we may call it early binding. But when it is happening during runtime, we call it late binding. And sometimes the word binding, we use it when we bind some objects to some methods, either during compile time or during runtime. You may bind, some object to a particular property and store some value during compilation or when you're writing your code. Or you can have some binding that happens when a program is running. Maybe program may request a particular method or a particular property to store some value, so that is late binding. Then virtual functions, I'll talk more about them when we shall be talking about abstraction. But simply, virtual function is a function that is made available in the abstract class, but it has no implementation. It has no implementation in the base class. Its implementation is found when you have derived class or when it is inherited. So that virtual function, it is just made available in the class, in the base class, but with no implementation, with no body. It has no body. It has no function definition. So when you implement such a function in another derived class, then you are creating what we call an interface, or it gives you a way you can create several interfaces. So when you define a function and it has no body, it has no definition, then it becomes a virtual function. And when you talk of pure virtual function, we are saying a function, it's a virtual function that has been assigned to a null or to a zero. That means it is simply a way of creating abstraction. We shall talk about abstraction when we shall be dealing with interfaces. Yeah. So I'm simply saying I have made available a particular tool to be used when you require. I have made available a particular function which you can use it when you require. It's like when you're building a house and you say, I make available a hammer, I make available nails, I make available this. But it's not a must that you have to use them at that time. But you can use them when you require them. That's what we talk of in creating an interface. Another example may be your television set. It has a lot of other functions which you don't know. Yeah, they are there, but for somebody who understands how to use them, he may use them, but probably don't know what they are being used for, but they have been made available for you. That's what we call some virtual functions which bring the element of interface. Now, we've talked about encapsulation as a concept in object-oriented programming. To encapsulate is to wrap something in a wrapper or to hide some details from being available to some quarters. So we have seen in object-oriented programming, especially when you're implementing a class, you can make some of the members private, or you can protect some of the members from being accessed outside. So that is one way of hiding information or encapsulation, whereby the things that are just reserved to the owner, you can make them private, or you can even make them static. So they are only available to that class where they are defined. But if you want to reveal them, then you can use some, access specifier such as public. So encapsulation is to hide the details. Sometimes in life, people are not interested in knowing so much. There are things that belong to you and they are hidden from others. An example will be whatever is in your brain. Yeah, it is you who knows. Personal information, your personal details. You have so much that you have within your brain, which may not be available to others until when they ask you some questions. Yeah, if you ask me my name is when you know I'm called Fred. But I know I am called Fred, and that is stored within my brain. I know I belong to this family and ABCD. But that information is not available to anybody until you invoke it or you require it. So those are examples of information hiding. So you may have some programs that really makes some things available, but some information also is hidden until when it is required. And that's why sometimes we talk of libraries. We talk of, some abstract classes which really are there, but some people may not be aware of them because you're not using them, don't require them. But to the person who requires that information, may have to call them and request for them. Another perfect example is the SIM card in your phone stores numbers of everyone, but the ones that are available are the ones which may be needed to perform some particular function. But your phone stores a lot of things and not necessarily using all of them. So that's information hiding. So in object-oriented programming, this concept is very important because not all your information may be there available to be used at that instance, but may be called upon when you require to use it. Okay? We can have a class of an example, maybe a class called Ali. And Ali has characteristics such as name and age, and has behavior, which are methods. He walks and he eats. So Ali, information about his age and name is stored. It is hidden. So I can make it private. Private name, private age. But his behavior I cannot hide. When he walks, everybody sees. When he eats, everybody sees. So that is not hidden. So those are functions or methods which are public, and everybody can see and can interact. That is why when you talk about state and behavior, state is about what data is stored and what is available to the person. Behavior is what can be seen and is modeled by using methods attached to objects. Advantages of encapsulation are for simplicity and clarity. All data and functions stored in the objects, it's stored there, and it is available, and it is in that. So it is very simple because an object will contain most of the data, which when you're implementing, it's available. So simplicity and clarity, grouping and summarizing. Low complexity is another advantage because functions work with data which they hide that. So you reduce the complexity of something when you create several functions with some data inside, or some behavior that is modeled within a function. So that means you're reducing the complexity, and we talk about modularity when you break down a complex thing into some simpler levels that you can implement that are understood. Again, for better understanding is when you group things together, you can easily make things be understood when you have groupings. So when you put things in an object, you're basically saying you are making your code and your program easily to understand, because you have those groupings where you see many things as one and one thing as many. Okay, so I've talked about virtual function, which I don't want to repeat. Virtual function is simply a function in a base class that is declared using the keyword virtual. So you have to use the keyword virtual, and when you're defining it in the base class, that virtual function, so in the implementation of that function will be in the derived class. So in the derived class, you have another definition of the same function virtual, but also you have its implementation or definition defined there in the derived class. And I've talked about pure virtual function is simply if you include a virtual function in a base class so that it may be redefined in a derived class to suit the object of that class, then you're saying that is a pure virtual function. I can have a function called area in the base class. So I just define it, but I don't have its implementation in the base class. Its implementation is in the derived class. Therefore, what I've done to the virtual function called area, I have made it a pure virtual function for me to implement it later in the derived class. So I will assign the function to 0. I'll say virtual, then my function is area is equal to 0. So I have made it a pure virtual function. And this is very important. I've talked about it because in the derived class you can have any form of implementation of the same function, or you can attach several meaning to it in the derived class. Data abstraction simply refers to providing only the essential information to the outside world and hiding the background details. So that's why we talk of abstraction. You only present to the world what is relevant to them and what is important to them, but the rest is hid from them. So data abstraction is a concept in programming and is basically used in design, whereby you make things available in a design, but during the implementation, you implement different things. Make some things available, but they are implemented differently in the interface. So in that way, you can have separation of concern. That's why we talk about a television, for example, when you turn it on and off, change the channel, adjust the volume and external components such as speakers, you attach them. But you really don't know the internal details, but you're just going through your television, you don't know the implementation. So they have abstracted it, they have hid some details from you. Okay, you can't just understand. And there's some functionality which are available in your television set that you probably have never used them, but they are available. So that's how abstraction is very important. Another good example is when you use functions such as cout and cin in C++. But these functions have been made available when you use the outstream, the streaming header file. So the implementation is in the header file. That's where they have been defined. But when you are using them in your code, you see, you really don't have to worry how they have been program to work or how they have been implemented. You just call them and you use cout and cin. So there is that abstraction. Okay, so abstraction is very important because you can hide some details. Not everything needs to be private, to be public. You can make some things private, and you can also have some different implementations of several functions. And this one also helps us to reduce the errors when we are doing our programming. So we protect either user entering wrong data. Okay, so we prevent some user level errors. Okay, and also we anticipating class implementation whereby you may have to debug your programs and you make them easier to debug. Okay, so thus far we have come. I'm sure we have talked so much about this. You can read more about interfaces, abstracts, and what have you. But that is the end of the chapter on polymorphism. You can pose any question or any comment if you have. Look at the examples which have been posted there, and you can revert back. So our next lecture will be on constructors and destructors, though I talked about them, but we shall also have a brief lesson on them. God bless you.